Let's take a look at question number one. It says in the diagram below, a sequence of rigid motions maps ABCD onto JKLM. The first thing I'd like to do is indicate corresponding angles. So I know that angle A, of course, matches up with angle J. I can see that B, angle K. We've got C aligned with angle L. And then lastly, D, of course, corresponds with angle M. All right, what else do we need to know? It says if angle A is 82 degrees, I'm going to indicate that right now. And it says if angle B is 104 degrees and angle L is 121, let's indicate that right here. The measure of M is what? So our objective is to determine the angle measure for angle M. Well, what do we know? We know that if we have a sequence of rigid motions, then angle measure is preserved. That means that this quadrilateral is congruent to this quadrilateral, and corresponding parts are congruent. That means that when I look at angle A, I know that it's corresponding with angle J. So I'm going to simply write in 82 right here, and that makes sense. I know that B corresponds with K, so I'm going to write in 104. And how do we figure out the angle measure of M? Well, I remember that the sum of the interior angles of a quadrilateral add up to 360. What we can do is we can subtract 121, 104, and 82 from 360, and what's left over will be the angle measure of angle M. All right, so let's do that together. So I know it's 360 minus, and it's going to be the sum of the other two angles that we know, 82 plus 104 plus 121, and 360 minus the sum of the other angles gives us 53 degrees. Is that an option? It sure is. The correct answer to number one is option number one, 53 degrees. Question number two says, parallelogram hand is drawn below with diagonals HN and AD intersecting at S. Which statement is always true? Well, I remember that one of the properties of parallelograms is that diagonals always bisect each other. All right, with that in mind, when we look at our four options, I can't help but notice that when we look at option 2, it says that AS equals 1/2 of AD. And that's true because the diagonals are bisecting each other. AD is twice as much as AS, and AS is 1/2 of AD, meaning that option 2 is our answer. Question number 3 says, the graph below shows two congruent triangles. Which rigid motion would map triangle ABC onto A prime, B prime, C prime? Let's take a look at our four options. We've got a rotation of 90 degrees counterclockwise about the origin. So here, of course, is origin. If we're shifting 90 degrees, this triangle would fall right here. That doesn't work, so we can eliminate option 1. We take a look at option 2. It says a translation of 3 units to the left and 3 up. So we'll start with A. If we go 3 to left, 1, 2, 3, and then 3 up, 1, 2, 3, you know what? That actually does match up. But I already know that if we're looking at vertex B, 3 over, 1, 2, 3, and 3 up, 1, 2, 3, it's pretty far away from B prime. So we know that that doesn't make sense. We can eliminate option 2. Uh, Option 3 says a rotation of 180 degrees about the origin. So that would shift this triangle somewhere over here. And I know that doesn't work because when we look at option number 4, it says a reflection over the line y equals x. And I remember that when y equals x takes the shape of something that looks a little bit like this, right? When x equals 1, y equals 1, and so on and so forth. And I also know that um, the distance from A prime to this line of reflection is congruent to the distance of A to the line of reflection. Likewise for B, we can actually take a look at that right here. So if we applied the distance formula, we could do this like so. We know that these lines are congruent, these lines are congruent, and of course these lines are congruent. So the correct answer to question number 3 is option 4. Let's take a look at question number 4. It says a man was parasailing above a lake at an angle of elevation of 32 degrees from a boat, as modeled in this diagram right here. If 129.5 meters of cable connected the boat to the parasail, approximately how many meters above the lake was this man? So that's our objective right now. We need to figure out how many meters above the lake was this guy. And I notice that this is a right angle, so we're going to be using our trig ratios to determine x, the length of this side right now. All right, if we're using trig ratios, I can think about this from the perspective of the boat. It's going to be, what is the relationship between this side and the boat? It's opposite, right? So it's going to be opposite over hypotenuse. That's going to be sine. We're thinking about the sine of 32 equals opposite over 129 and a half. So x equals 129 and a half sine 32. When you pop that in your calculator, we can figure out that x equals 68.6245 and so on. Uh, we're rounding. It says approximately. And I noticed that of these four options, option number one, 68.6, is the correct answer. Question number 5 says, a right hexagonal prism is shown below. A two-dimensional cross-section that is perpendicular to the base is taken from the prism. Which figure describes the two-dimensional cross-section? Well, I know that if it's perpendicular to the base, it might look like this. So this, of course, is one base. This is the other base. And I know that when we connect this, what happens? We've got a rectangle. Beautiful. So this is what the cross section is going to look like. Clearly, this is not a triangle. This is not a pentagon nor a hexagon. In fact, I remember that a cross section perpendicular to the base of any prism will always result in a rectangle. Let's take a look at question number 6. It says in the diagram below, AC has endpoints with coordinates -5, 2, and 4, -10. If B is a point on AC and AB to BC is a 1 to 2 ratio, what are the coordinates of B? There's a few ways we can do this. The first way, the non-mathematical way, is we know that if it's making a 1 to 2 ratio, it's going to be splitting the segment up into 3 congruent parts. And I'm simply going to eyeball it and recognize that if it's splitting into 3 congruent parts, I know that right here we've got our first segment, we've got our second segment right there. Here we've got 3 congruent parts, right? We've got part 1, part 2, part 3, and B is situated where it splits up this segment into a 1 to 2 ratio. That means that B is going to be splitting it up right here, right? And if we back out in a moment like this, where is this? This is 1, 2, 1, 2. So this is -2, -2. Is -2, -2 an option? It sure is. It is -2, -2. That is actually the correct answer, but that's not how we want to solve this problem. We're going to want to do this mathematically, but you can always like sort of reason your way through many of these problems as we just did a second ago. All right, how else can we solve this problem? Well, as we said, this segment AC is going to be split up into 3 congruent parts, right? We've got, sorry, C right here, so we've got 1 congruent part, 2 congruent parts, 3 congruent parts, great. And I know that the X values are -5 and 4. Great. I know that the y values are 2 and -10. Great. So what we could do is we could figure out the distance in terms of x values from A to C, and then y values from A to C, divide it by 3, and we can figure out what that coordinate is right there. So how exactly are we going to do that? Well, let's start with the x values. We can do 4 minus -5, and that's going to give us 9. Now let's figure out the y values. We've got -10 minus 2, and that's going to give us, of course, -12. And so what exactly does that mean? Well, that means that the x values are increasing 9 by 9 from left to right, and then the y values are decreasing by 12. And we could have also just simply counted this on this grid right here, right? 9 to the right and 12 down. All right, so now we know the distance in x and y values. Because this is going to be in a 1 to 2 ratio, we're going to be dividing into 3 parts. We're going to divide 9 by 3, and that, of course, gives us 3. We'll divide -12 by 3, and that's going to give us -4. All right, so we're going to be shifting from A, 3 to the right, +3, right? x values, right? 1, 2, 3. And then we've got 4 down. 1, 2, 3, 4. And as we said a moment ago, B is situated at right here. It's situated at -2, -2. And that, of course, is our answer. Number 7. An ice cream waffle cone can be modeled by a right circular cone with a base diameter of 6.6 centimeters and a volume of 54.45 pi cubic centimeters. Let's sketch that out right now. So it's going to look a little something like this. And it says, what is the number of centimeters and the height of the waffle cone? All right, so let's think about what we know. We know that the diameter, of course, is 6.6. And our objective is to figure out what the height is. Next thing I'm going to do is I'm going to jot down the formula for volume of a cone, and I remember that it's 1/3 pi r squared times the height. All right, so when we plug in the values we already know, I know that it says that the volume of the ice cream cone itself is 54.45 pi cubic centimeters. So I'm going to jot that right here. So let's do that. Let's plug in these values. Equals what? So we know it's 1/3 pi, and then the radius. We don't have the radius right now, but I do know that half of 6.6, of course, is 3.3, so it's going to be 3.3 squared, and we don't know the height. That's our objective, and so we're going to be isolating h ultimately. All right, so let's keep cruising. I know that if we simply carry this down, if we simplify, uh, the radius squared is going to give us what? It's going to give us, once we pop this in our handy dandy calculator, it's going to give us 10.89 times the height. And when we divide 10.89 by 3, or multiply it by 1/3, that's going to give us 3.63 pi h. Okay, simply carrying this down. What do we need to do now? We want to isolate h, right? That's what we said a second ago. So if we divide both sides by 3.63 pi, what do we get? H is going to be 15. Amazing. Now we didn't even check our options yet, but is that an option? It sure is. It is option number 3. That, ladies and gentlemen, is the answer. Question number 8 says, the vertices of triangle PQR have coordinates 2, 3, 3, 8, and 7, 3. Under which transformation of triangle PQR are distance and angle measure preserved? All right, that is really important. If distance and angle measure are preserved, then what we do not want is a dilation, because distance and angle measure would not be preserved. So we don't want any dilations. Let's take a look at our options. When we look at option 1, we see we've got our original coordinate, and we see that the x is multiplied, and the y value is multiplied. We don't want any scalars. This is a dilation, so we can eliminate option number 1. When we take a look at option 2, I can see that the y value is multiplied by 3. That's a dilation, and we don't want that. When we look at option number 3, I can see that the x value is multiplied by 2. Again, that's a dilation. We're not looking for that. However, option number 4, I can see that we've got our original coordinate, and we've got x plus 2, and we've got y plus 3. That's a translation. Translations are good because distance and angle measure are preserved. Option 4 is our answer. Question number 9. In triangle ABC shown below, we've got side AC is extended to point D with angle DAB equal to 180 minus 3. We've got angle B equals to 6x minus 40. And we've got angle C equals to x plus 20. What is angle BAC? Our objective is to figure out what the angle measure is of this angle right here. How do we do that? Well, I remember a few things. Among the things that I remember is that the exterior angle is equal to the sum of the two opposite interior angles. So this red angle right here equals these two green angles. And so let's set that up right now. So I know that 180 minus 3x, which is the exterior angle, equals, again, the sum of the two interior angles, which is 6x minus 40 plus x plus 20. And when we combine like terms, what does that give us? That gives us, so let's carry this down, 180 minus 3x equals 7x minus 20. Great. And so when we subtract 20 from both sides, and when we add, actually, sorry, 3x to both sides, we now have x equals 20. All right, so I'll write that right here. X equals 20. That makes sense, right? But that's not what we're looking for. If we plug 20 in for x, let's do that right now when we're looking at that exterior angle, 180 minus 3, and we'll plug in 20. What does that give us? Well, 180 minus, and I know that 3 times 20, of course, is going to be 60. So 180 minus 60 is 120. All right. So this angle right here, this angle is 120 degrees. I also know that this is a linear pair, so that means that angle BAC is 60 because 60 plus 120 gives us 180. All right. So this is our answer. So the correct answer is option number 3. Question 10 says, circle O is centered at the origin. In the diagram below, a quarter of circle O is graphed. Here we've got that quarter. Which three-dimensional figure is generated when the quarter circle is continuously rotated about the y-axis? So here we've got the y-axis, of course, and if it's rotated about it, it's going to look a little something like this, and it's going to create this sort of 3D shape, right? A little bit like a bowl. And what does a bowl kind of look like in this context? A hemisphere, option number 4. Question number 11 says, rectangle ABCD prime is the image of rectangle ABCD after a dilation centered at point A by a scale factor of 2, 3. Which statement is correct? First, however, let's think about what this means. So we've got our initial triangle, our pre-image, which we'll call ABCD, right? And then we've got the image, which is A prime, B prime, C prime, D prime, and it says that there's a dilation of a scale factor of 2/3, meaning that it's getting smaller. All right, so which statement is correct? So we know that this is a, all right, so this is A prime, B prime, D, C prime, D prime. It's decreased in size by a scale factor of 2, 3. And so I know that when we're looking at option 1, it says rectangle ABCD prime has a perimeter that is 2/3 the perimeter of rectangle ABCD. Yeah, so that's certainly true, right? Because of the scale factor involved. Here I noticed that it says the same thing except the perimeter has a scale factor of 3/2. No, that's not true. We can eliminate that. When we take a look at option number 3, it says that, ooh, it has an area that is 2/3. Nope, that doesn't work, nor does option 4 work, because likewise it has an area of 3/2, the area of the initial one. Nope. The correct answer is option 4, because rectangle ABCD prime has a perimeter that is 2/3 the perimeter of the original or the pre-image. Question number 12, it says, the equation of a circle is x squared plus y squared minus 6x plus 2y equals 6. What are the coordinates of the center of the circle and the length of the radius of the circle? The first thing that I'm going to do is I'm going to jot down the equation of a circle, which we remember is x minus h squared plus y minus k squared equals r squared. And we remember that r is the radius. We remember that hk is the center of the circle. All right. How do we do that? How are we going to figure this out? Well, what we need to do is convert this equation into the center circle of equation form. To do that, we're going to need to complete the square. So I'm going to rewrite this equation.
But I'm going to group the x and the y's. So I have x squared minus 6x plus y squared. And actually what I'm going to do is I'm going to leave a little gap. And you're going to see why in a minute. Plus y squared plus 2y. Again, I'm going to leave a gap equals 6. All right, so we need to complete the square. And to do that, we need to figure out what c is. And we remember that to determine what c is, it's going to be b divided by 2 squared. And in this case, b is negative 6 and positive 2. So let's see. So negative 6 divided by 2 is negative 3. Squared is positive 9. If we add something to one side, we've got to add it to the other. And I know that 2 divided by 2 is 1. 1 squared is plus 1, so we're going to add also a 1 to the right side. Amazing. All right. So now what we're going to do is factor these perfect square trinomials. So I see we've got x squared plus 6x plus 9. And we've got y squared plus 2y plus 1. All right, so let's factor these. On the left side, we're going to have x minus 3 squared plus y plus 1 squared equals what? 6 plus 9 plus 1 gives us, of course, 16. Amazing. All right. All right, so last step. Let's rewrite this equation so that we can determine what the radius is. And I know that if it's r squared, it's going to be simply 4 squared. So what does that mean? This means that h is positive 3. I know that k is going to be negative 1. And I know that the radius, obviously, is simply 4, meaning that the correct answer is option 2. The center is 3, negative 1. The radius is 4. Question 13. In the diagram of ABC below, DE is parallel to AB. All right, so we just marked it up to indicate that they're parallel. I can also see that it says CD is 15, AD is equal to 9, AB is equal to 40. Our objective is to figure out the length of DE. So we're trying to figure out this length right here. We'll describe it as X. How are we going to go about doing that? Well, I know a few things. Among them is that if DE is parallel to AB, that means that this angle right here is congruent to this angle. And that also means that this angle is congruent to this angle because they're corresponding. So we just established AA similarity. So that means that this triangle right here, this small triangle, is congruent. I'm sorry, it's similar, not congruent, similar to the big triangle. Amazing. So now what we can do is set up a proportion. So we'll do small triangle to big triangle. And we'll do the side length of the small triangle over the base of the small triangle equals the side length of the big triangle, and it's not 9, it's 15 plus 9, which is 24, over the base of the big one, which I can see is 40. We're going to cross multiply, so we'll have 24x equals 15 times 40 is 600. We're going to divide both sides by 24, and when we do, x equals what? 25. Is that an option? Sure is. The correct answer is option number 3. Let's take a look at 14. The line whose equation 3x minus 5y equals 4 is dilated by a scale factor of 5/3 centered at the origin. Which of the following 4 statements is correct? The first thing I'd like to do is break this into 2 parts. So I see that we've got a line dilated by a scale factor of 5/3, and I also see that it's centered at the origin. This is critical because we need to remember that dilating a line, what happens? Equals the slope does not change. All right, but what about the y-intercept? Well, if the y-intercept was on that original line, then the y-intercept would be the same. But in this case, that's not true. We can take a look at that further in a moment. I can see that it's centered at the origin. So what I'm going to do right now is I'm going to rewrite this equation. All right, so we're going to plug in the x and y values. And if it's on the origin, then we remember that it's at 0, 0. And this does not check out. So this means that it is not on the original y-intercept. So critically, let's take a look at our options. It says, for option number 1, it says the image of the line has the same slope as the pre-image, but a different y-intercept. And in fact, that is the correct answer. That's because, once again, the slope does not change when we're dilating, but it does have a different y-intercept. Question 15. Which transformation would not carry a square onto itself? Let's start by creating a square, then we'll evaluate the 4 options. So here we have a square, and option 1 says a reflection over one of its diagonals. So let's draw a diagonal, more or less, and when we take a look at this, if we're looking at this green line, it would in fact map onto itself, right? So we can eliminate 1 as an option because it does carry onto itself. All right, so we know it's not option 1. Option 2, a 90-degree rotation clockwise about its center. So if we imagine this is the center more or less, and it's rotating 90 degrees, we know that it's more or less going to look, it will look exactly the same. So we know that option 2 is also not one of the answers. So it's not 1, it's not 2. Let's take a look at option number 3. It says 180-degree rotation about one of its vertices. We'll create a new, let's say, all right, so we've got a new square, and it's going to be rotating around one of its vertices. Let's pretend that vertices is the upper right-hand one, and it's going to be rotating 180 degrees. And what we're going to do is we're going to copy this. Let's copy this. All right. So here we've got a duplicate of this square, and we're going to be rotating it 180 degrees more or less. So I'm just ballparking it. There's 90 degrees, and there more or less is 180 degrees. Is this mapped onto itself? No, it is not. So we know that option 3 has to be the answer. 180-degree rotation about one of its vertices does not carry a square onto itself. And if we take a look at option 4 real quick, just to rule it out, it says a reflection over the perpendicular bisector of one of the sides. So here is a bisector, perpendicular, and we can see pretty clearly that it would in fact carry over onto itself if we're thinking about this line cut right smack down the middle of the perpendicular bisector. Again, the correct answer is option 3. Question number 16. It says, in circle M below, diameters AC, chords A, B, and BC, and radius MB are drawn. Which statement is not true? So this of course means that 3 will be true, and we've got 1 false statement. That's what we're looking for. Let's start with option 1, and it says triangle ABC is a right triangle. Well, it kind of looks like one if we're just eyeballing it, but that's not enough. What I do know is that we've got a inscribed angle right here from ABC, and I also know that it intercepts this diameter, right? And so I know that a inscribed angle is 1/2 its arc, and I know that this, of course, because it's the diameter, this is 180 degrees, so I know that this has got to be, ABC has got to be 90 degrees, and this is a right angle, so this is true. ABC is a right angle, so option 1 does not work. What about option number 2? So it says ABM is isosceles. Let's take a look at this a little bit further. I notice a few things. An isosceles triangle has to have 2 sides that are congruent. And I know that AM and BM are congruent because they're both the radius, right? So what does that mean? That it is isosceles. We can eliminate option 2 as a possibility because that is true. Option 3, arc BC, which we have right here, is equal to angle BMC. Is this true? Is this the case? It is, because we know, of course, this is a central angle, right? M is the center, and central angles are equal to the arc, so we know that we can eliminate option 3, and that means that by process of elimination, option 4 has got to be the answer. Let's take a look at it a little bit further just so we can verify it. So we've got arc AB, is equal to half of angle ACB. And I remember that ACB is the inscribed angle of arc AB. But what I also know is that this arc is twice as much as the inscribed angle. So if this is 80 degrees, then ACB's got to be 40 degrees. But that's not what this is saying. This is saying the opposite of this. It's saying that this arc is equal to half of ACB. For this to be true, we would need to double 40 so that 80 equals 80. And this would have to be, instead of 1/2, 2. Correct answer is option number 4. Question 17. In the diagram below, XS and YR intersect at Z. Segments XY and RS are drawn perpendicular to YR to form triangles XYZ and SRZ. Amazing. Which statement is always true? And so that's really critical, and I'm going to highlight that right now. This means, of course, that 3 are not true, 1 is. And before we do anything else, let's mark up this diagram. And I notice it says that segments XY and RS are drawn perpendicular to YR. So I'm going to indicate that right here. These form 90 degrees, of course. And then what else do I notice? I can see that XZY and RZS are congruent because they're vertical angles. That makes sense. And once we do this, we've established AA similarity between these two triangles. So now that we know that it's similar, we can indicate that XY is corresponding with RS. We know that YZ corresponds with RZ. And finally, we can confirm that XZ corresponds with SZ. All right, so now we know this. Let's take a look at our 4 options. And I know that option 1 is a cross product, which is a result of a proportion from similar triangles, so 1 could be an option. Also, option 4, it's a proportion created as a result of similar triangles. When we look at option 2, I can see it involves congruence. It says that this triangle is congruent to this triangle. Likewise, option 3, it says that this segment is congruent to this segment. And we can eliminate those because these triangles being similar doesn't guarantee that they're congruent. So we can't assume that corresponding parts are congruent. So we can eliminate option 2 and option 3. Let's take a look at option number 1 a little bit more closely, and let's reverse engineer this cross product to determine what the potential proportion is. So I know this might look like XY over XZ and RZ over SR. And let's create this proportion right now. So XY over XZ equals RZ over SR. Okay, and what do I know? I know that XY is the blue. I know that SR is blue. I can see that XZ is red. And I see that RZ is green. So it should be red over blue over red equals blue over red. Or it should look like, in this case, short side over hypotenuse equals short side over hypotenuse, but that's not what we have here. This is not true. So we can eliminate right now option number 1, and that leaves option number 4. And let's take a look at this a little bit further so I can see that it says XY over SR. So XY is what? So we've got blue over blue equals YZ, which is green, right here, right? Equals green over RZ. Green over green. So it's, once again, it is short side over short side equals long side over long side. This is similar. This is an appropriate proportion. 4 is the correct answer. Question 18. As shown in the diagram below, line ABC is parallel to EFG. All right. And it says segment BF is congruent to EF. Amazing. All right. And we know that it says if angle CBF is 42.5 degrees, then we need to figure out what the measure of angle EBF is. So I'm going to indicate that right now. So CBF is 42.5 degrees. Our objective is to figure out EBF, which is this one right here. I'm just going to write X. So that's our objective. Well, what do I know? I know that if we've got a two parallel lines, as we do right here, and we've got a transversal cutting across, I know that this angle and this angle are congruent because they're alternate interior angles. Well, what does that mean for us? That means that this angle right here is also 42.5 degrees. Amazing. All right. But how are we going to figure out what x is? Well, crucially, it says that this segment and this segment are congruent. And that's important because this forms an isosceles triangle. And I remember that an isosceles triangle has two sides that are the same. And I also remember that the base angles are congruent. So that means that if this angle is x, then this angle has also got to be x. So I'm going to indicate that right now. Boom. What other information do we have here? Well, we've got three interior angles of this triangle, and I know the sum of the three interior angles add up to 180. So I'm going to write x plus 42.5 equals what? Equals 180. Let's combine like terms, and when we do, we have 2x equals what? Well, we can't forget that we need to subtract 42.5 from one side. We got to subtract it from the other. And so now we have 2x equals what? 180 minus 42.5 gives us, when I plug into the handy dandy calculator, 137.5. All right. So now what we need to do is divide both sides, of course, by 2. And x equals what? 68.75. Is this one of our options? It sure is. It's not 3, 4, or 1. It's option number 2. So x equals 68.75 degrees. Question 19. A parallelogram must be a rhombus. And I'm going to loosely draw a rhombus right now. It says it must be a rhombus if its diagonals what? So I'm going to draw the diagonals like so. And let's take a look at our options right now. It says are congruent. Well, here are the diagonals. They are not congruent. They are congruent for a rectangle, not, however, for a rhombus. So we can eliminate option 1. Bisect each other. Nope, that's what they do for rectangles, so we can eliminate that. Do not bisect the angles. No, the angles are actually bisected, so we can eliminate this. And option 4 says are perpendicular to each other. And yes, that's true. These diagonals are perpendicular. That's the property of a rhombus. So option 4 is the correct answer. Question 20. What is the equation of a line which passes through 6, 9 and is perpendicular to the line whose equation is 4x minus 6y equals 15? So to do this, we're going to need to figure out what the slope is for this equation and then rewrite it in point slope form. We're going to evaluate the 4 options in a moment, but let's first convert this to slope intercept form, and we're going to do that by isolating y. The first thing I'm going to do, however, is rewrite this equation. So 4x minus 6y equals 15, and we're going to subtract 4x from both sides because we need to, of course, isolate the y. So we've got negative 6y equals negative 4x plus 15. All right, and now what we need to do is divide both sides by negative 6. And y equals 2/3 x, right? It's 4/6 x, but we can simplify that to 2/3 x plus 15/6. All right, and so what's really critical here, once again, is the slope. And I can see that the slope, in this case, is 2/3. Great. So the perpendicular slope is going to be the opposite reciprocal. So we're looking for an option that has negative 3/2. So this is what we're looking for. All right. And when we look at our 4 options, do any of these guys have negative 3/2 as a slope? Sure does. So I'm looking at option 1 and option 3, meaning we can eliminate right now option 2 because we see the slope is 2/3. Here we see option 4 has a slope of 2/3. We can eliminate that as well. And I remember that point slope form is expressed like, is written like y minus y1 equals m times x minus x1. Great. And so what does that mean? We're going to be plugging in the y value and the x value, and we know that we want it going through 6, 9. So what would be the appropriate choice? I see here it's y minus 9, here it's y plus 9, here it's x minus 6, and x plus 6. Well, if these are positive values, right, we're going to be plugging them right into this equation. I know then it's got to be option number 1, and this, of course, is our answer. Question 21. Quadrilateral ABC is inscribed inside circle O, as shown right here. And it says, which statement is true? Basically, we need to solve for x. We've got to solve for y. How do we do that? Well, whenever we have a quadrilateral inscribed inside a circle, opposite angles are what? They're supplementary. That means that they add to 180 degrees. That means that this angle and this angle add up to 180. That means that this angle and this angle add up to 180. Let's do that right now. We'll start with angle A and C. And so again, I know that angle, well, 80 degrees rather, plus y plus 30. If they're supplementary, they equal 180 degrees. If we combine like terms, I know that 80 plus 30 gives us 110 plus y equals 180. And then if we subtract 110 from one side, we're going to subtract it from the other. I know that y equals 70. Amazing. What about the x's? So I know that 75, if we're looking right here, 75 plus x minus 10 equals 180 degrees. I know that 75 minus 10 gives us 65 plus x equals 180. We're going to subtract 65 from one side if we've got to do it to the other. And x equals what? 115. Now, is that an option where x equals 115 and y equals 70? It sure is. Option number 4 is our answer. Question 22. A regular pyramid has a square base. So I'm going to draw this square base right now. And I know that this is a pyramid, so let's say I'm just sort of eyeballing this. All right, let's say it looks a little something like that. All right, and it says the perimeter of the base is 36 inches. So 36 divided by 4 is what? It's 9. So this side is 9, likewise this side is 9, 9, 9, all the way around. Okay, and it says the height of the pyramid is 15 inches. Oh, okay. So like from right here all the way down is 15. All right, and it says, what is the volume? All right, so that's what we're looking for right now, of the pyramid in cubic inches. All right, the formula for volume of a pyramid, of course, is volume equals 1/3 base times height. And I know that when we're talking about base, in this case, because it's a square, it's the side squared. Amazing. So let's plug in values for this pyramid. So it's going to be 1/3. What is the base? Well, the base is the side squared, so it's going to be, of course, 9 times 9. So we can simply write 9 squared times the height. What is the height? I can see that right here we indicated that it's 15. And when you plug that into your handy dandy calculator, you're going to get 405 cubic inches. And is that an option? It is. Option number 2. Question 23. In the diagram below of triangle ABC, angle ABC is 90 degrees. It's a right angle. I see that AC is 12. I see that AD is 8. And we've got altitude BD drawn. What is the length of BC? So this is our objective right now. Well, the first thing I know is that we're going to be creating a proportion to determine what BC is. And to do that, we're going to need to establish similarity between this triangle, this small triangle right here, and the overall big triangle. We can do that because a small triangle has a 90-degree angle. Likewise, the big triangle has a 90-degree angle. And they both share angle C. And so that's, of course, reflexive property. So we've got angle-angle similarity. So let's set up this proportion. Before we do anything else, we're going to need to figure out what the short side is of this leg right here, of this triangle right here. And we know, of course, that CD is 4, and we can figure that out. We know that the entire length of the hypotenuse of the big triangle is 12. 12 minus 8 gives us 4. Tremendous. So let's set up this proportion. So we'll set it up like the short leg of the small triangle over the hypotenuse of the small triangle equals what? Well, we don't know what, if we're looking at the big triangle now, we don't know what the short leg is of this triangle, so we're going to describe it as x over the long leg of this triangle, which we know is 12. Does that make sense? So once again, very quickly, we've got short leg over hypotenuse equals short leg over hypotenuse. So that's the proportion that we set up. Now we're going to simply cross multiply, and I know that x times x gives us, of course, x squared. I know that 4 times 12 gives us 48. And so what we're going to do is we're going to isolate x, and we're going to take the square root of both sides. So now we've got x equals the square root of 48, and we can simplify this. We know that, is there a perfect square in radical 48? There sure is. So we can set this up like radical 16 times radical 3 equals radical 48. And because 16 is a perfect square, I know that we can simplify this to simply 4 radical 3. Is this an option? It is. It's option number 2. Tremendous. Last question, number 24. In the diagram below, we've got two concentric circles with center. Oh, they share the same center in radii OC, OD, OCE, and ODF. It says if OC equals 4, and I'm going to write that right now, OC equals 4, and it says OE equals 6. All right, I'm going to include that right there. Which relationship between the length of arc EF, and let's do this right now, EF and the length of arc CD is always true? Well, I know a few things. I know that these two circles share the same center, and I can see that this outer circle is a dilation of the inner circle. But before we discuss that any further, let's take a look at our options. I noticed that option 1 says the length of arc EF is 2 units longer than the length of arc CD. No, so I can see that that's true of the radius, not of the arc. So what we can do is we're going to eliminate option 1. And when we look at option 2, it says the length of arc EF is 4 units longer than the length of arc CD. No, that's also not true. But what might be true is option 3 or 4. It says the length of arc EF is 1.5 times the length of arc CD. So essentially that's saying the scale factor of EF to CD is 1.5, and option 4 says the length of EF is 2 times the length of arc CD. So, or is a scale factor 2. So how can we figure that out? Well, I know that if we're thinking about the relationship between the length of EF, and I know that the radius for this blue arc right here is 6. All right, OCE is, or OE rather, is simply 6. And it says that the radius of OC, of course, is 4. We can figure out what the scale factor is by simplifying right now, and I know that simplifies to 3/2 or 1.5. So the scale factor from CD to EF is 1.5, meaning that the length of arc EF is 1.5 times the length of arc CD. The correct answer, ladies and gentlemen, is option 3.